Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up my World Time plugin version 1.0 for your own projects. So the World Time plugin allows you to have a custom timescale for your game measured through a game calendar resource. So you'll be able to customize how fast the game goes and the scale of things operating within the time systems. So some key functions of the plugin include being able to define time of days, where a certain marker period of the day, like entering the 6th hour of the day for dawn, occurs, and you'll be able to set up your own triggers based off of the signals for that time of day being entered. Also, using the aging system, you are able to take objects that exist inside of your game world and have them increase their age value as the game time progresses. So the aging is set up to whatever scale you want. That could be 1 hour, 4 hours, a day, a week. It could even be a second. And then you should be able to create your own custom triggers based off of the age of an object reaching certain thresholds. For instance, there is a built-in scene replace function for objects that have an aging component, where you'd be able to replace one scene, like let's say the seeds for corn, with the next level of that corn stage, becoming a seedling plant and then eventually a fully developed mature plant. So I'll try to cover all of that in today's video and go over some of the changes from the pre-release versions of World Time. Okay, now if you look at my Godot screen, you'll see that I have a level set up. And in this scene, you can see that this is just a root 2D node and then the different textures and objects that would exist inside of that scene. Normally you would use a tile map, but I just wanted to make it quick and easy. So this right here is actually just a sample map from the Kenny roguelike base pack. So just something to look at as we add in components like the time of day, directional light 2D, which will be able to change the lighting based on what time of day your day-night cycle system is currently in. Okay, then if I go over to the left in the scene tabs, you can see that I have another scene here, top-down simple main. So I am calling this main as the main gameplay scene for this project, and it is going to actually load the top-down simple level inside of the scene hierarchy here. So it's going to be adding the level under the world. So what I wanted to demonstrate with this is that as you switch your levels around, the systems should still be able to exist once in the background. You set it up and then they just persist as you keep changing your levels in and out as your character moves around the game world. So I already wrote up a little script that's going to load that level scene straight into here, into the game world. So if I run this scene, it's going to load the level as a child of the world. And just FYI, before I get into it, I'm going to be including this in the demo project for the plugin. So if you want to understand everything that I've been going over in this video, it should exist in the demo project for anyone using the plugin. So let's go ahead and get started with adding the systems in. In my hierarchies, I like to have a node that holds all of my game systems that is separate from the world. So if I mess with the world, it's not going to affect the game systems itself, as long as I have those systems nested in the main gameplay scene here. So I'm going to right click on my root and I'm going to add a child node for just a standard node, and I'll rename it systems just to kind of give it a category there. And I might just reorganize this to the top, and then we want to add in the systems from the plugin. So the one that is required for the plugin to work is the game time system. So let's add a child node and search for game time system or just game, and we'll add that in. So the game time system is responsible for updating the world time state with the current game seconds and date time based on the passage of actual time in the game. So as your process function has the delta, which is the time between frames, that gets modified into your game time scale and updated on the world time state. So you can have the game speed move at 2,000 times real world speed, so it only takes a few real life minutes for your game to actually go a whole day, which is part of the point of the plugin. So we need to create those resources over here on the right. So in other versions of the plugin, the world time state would have been the time signal bus. The state goes one step beyond just signals in that it also stores the properties for the time state. So if you have seconds elapsing, that value gets stored here. And since this is a resource, it should be very easy to save to a file if you need to do that for data persistence. And since it is of type resource, it should be very easy to save and load from a file if you need to do that. So we're going to create a new world time state. I'll just click on this drop down, new time state. If you expand it, you'll see some values like the game seconds and date time, time of day. You don't need to worry about updating any of this because the game time system is going to basically set these values as soon as the game system loads. And then the other system that interacts here is the day-night cycle system, which will set the time of day, last time of day, and transition progress based on whatever the current game seconds of the time state are. Okay, so then we need time movement settings. I'll create that resource. So anything that was a setting on the game time system before is basically going to be here. If you want your time to progress automatically and switch days, then you're going to leave auto change day checked. If you leave auto increment time checked, then that's going to allow the game time system to actually increment the time without manually calling the functions on the game time system. So you probably want those both checked. The game time speed is basically the multiplier times the real life time that occurs in your game for how fast you want time to progress. So if you want a minute to take 1 second, then you would make it 60. So 60 times 1 gives you 60 game seconds for every 1 second of game time. So feel free to change the default value to whatever makes sense for your game. And then the calendar is going to be a shared resource, which calculates all of the time converting from game seconds to hours time, game dates, and date times, which is a composition of a game date and an hour time within your game. Now, you don't need to define your own game calendar, though you can by clicking New Game Calendar here and creating game years. You can even create a custom timescale if you want, which can define how many seconds per minute, minutes per hour, and hours per day for your game. Obviously, if you change those values from the real world values, it might be kind of confusing for players, so it's an option, but probably doesn't apply to most people. And of course, you can define what a year should look like, how many days are in each month, and how many months. But if you want to keep this simple, just click on this dropdown and do quick load and find the default game calendar from the plugin files. If you do that, then it's just going to default with a standard 365-day calendar with no leap years. So if you have 1 year inside of this, that's going to just loop that same year, the same days, same months for every year of your game. So this would just be a 365-day calendar that basically reflects the real world. And you could just leave that as the default, at least for your initial testing. Okay, so that is basically all of the setup for the game time system. I tried to clean things up and make it straightforward. Also, each of these resources can be saved to a file both within the editor or during gameplay, of course, with Resource Saver and Resource Loader if you need to do so. So the next thing we're going to do is take the world time state and actually save this to a file. So I'm going to right click it and do Save As. So I'm going to go into my demo project, the top-down simple demo. So I'll create a folder for states, which is just going to be the saved resource for any state type resource inside of our game project. And I'll rename this world time state. Now the world time state resource is going to be something we need to reference across our other world time systems, but also any component that we might attach to a scene like a character or an object in the game that needs to respond to the signals that exist on the state. So for instance, if we want something to happen, like updating the UI, whenever the world time state is updated, we would simply reference the same world time state and then update the UI whenever the signals get emitted. Okay, so we can actually demonstrate a good example of that with a UI display that will actually reflect the world time state. So in my main hierarchy, I'm going to create a canvas layer for UI. I'll right-click the root, add child node, canvas layer, which is a way of separating different objects inside of your scene. So let's create that. So if I go to the file system in the bottom left and I search for display, then you should be able to see two display UIs that exist out of the box for the plugin. So time of day display is more for the day-night cycle system, but we can use the DateTime display right now. So I'm going to add an instance of this to my canvas layer, and that'll just be centered at the top of the screen. You'll see that here we need to reference a state, the time state we want to reflect in the UI, which of course is the world time state. And then we need a format settings resource for how each of the time elements should be displayed as a string on the screen. Okay, so let's go to the state and quick load the world time state from the top-down simple states. Okay, that's the one we want. And then we can just create a new time format settings resource. If we want, we could right-click this and save it to the project as well. So if I go up a directory to the root of the top-down simple project, I'll create a new folder, and we can just call this settings, and I could do time format settings.trs if I want to do that. And then this could just be a consistent format settings for any objects in our game, any UI that want to reuse these same settings. So you can see the reusability of resources are very powerful in Godot. Okay, and that should pretty much be it for that. So let's go ahead and run the main scene and see if our UI is displaying up there. Okay, there we go. We have our day, month, year from the time state, and we have the hours, minutes, and seconds that, as you can see, is going at 2000 times speed for our game. Now, nothing's really reacting to anything else happening in the scene, just the UI is showing what occurs on the time state through the signals that that time state has. So if you need to do any kind of event-based stuff, look at the signals on the time state and later the aging state as well, and that's where the bulk of what you need is going to be. Now, if we want things like time of day lighting, then we need to add in the day-night cycle system so that those times of day can be defined based on the settings that we choose. So let's right-click on Systems and add in a child node, day-night cycle system. Add it in. As you can see, we need the world time state here again. So we're going to quick load that from our project. Okay, it's set. So same resource, it's 3 different locations, and the nodes don't need to actually talk to each other directly because everything is being handled through the state. And then times of day. So we need a time of day set. So if I create this resource and we expand it, then you'll see that this is going to have an array of times of day. So as one set, it becomes easier to save and share across multiple objects once again. But we need to define our array here. So let's create 4 different times of day. And each of these are their own resource. So I'll click new time of day, new time of day, new time of day, new time of day. And for each of these, we just define what we'd like it to be. So I've been liking to test the plugin by creating a dawn, a daytime, a dusk, and a nighttime, but you can create as many as you want to respond to inside of your time of day set. So let's do dawn, and then I will do a enter time, which is an hours time. So if we create that resource, it's hours, minutes, and seconds. So just think of hours in a day. If you're talking about hour 6, that means 6 a.m. And this would be for like 24-hour times. So 16 would actually be 4 p.m. if you're working in AM, PM. So if we want dawn to just be 6 a.m., then we just put a 6 here. And that's basically everything we need to do. You can also add in minutes and seconds if you want to go a little further down for that. And then transition duration. So when you enter a time of day, how long do you want it to take before that time of day is considered to be fully transitioned into? So we hit 6 hours, it is dawn, but for the sake of transition-based stuff like lighting, we can create a game time duration here for this. So how long do we want the transition to take? So if we say it takes 30 minutes to fully go from nighttime to dawn, once dawn officially triggers, then we can make it 30 minutes right here. And these times basically all get converted internally back to game seconds. So putting it at this scale is just a much more human readable way of understanding it. Like 1 day of time is a lot better than, I think it was like 86,400 seconds. So, you know, if you want it to last a day for a transition, then you can do that. So if we want 30 minutes, it's going to take 1800 seconds of game time, assuming our time scale hasn't been changed, in order to become fully into the dawn time of day. And we can set a display color for this time of day. So this is going to be the color that represents the time of day, not necessarily the lighting color that would exist inside of the game scene. So this is more of a UI color selection here. So what color do you want to represent time of day dawn? I might make that like a light blue. Now, the reason these colors are so dark default is because on the time of day display, which we'll add in a second, the default color text is white. So dark plus white works better. And so that we can just see that real quick, I'll actually add the time of day display under the date time display. And let's offset it by a little bit to like down there. As a child of the parent, if I move the parent, they both move, just FYI. And then this time of day display is also going to need the world time state. So let's quick load the world time state, and then that sets up this element. But we still got to finish up with defining the times of day. Okay, so we have dawn done. Now we just do the same for daytime. So I will write in daytime, if you prefer 1 word or 2 words for that. And then a new hours time for enter time. This should be after the first hours time. Now these shouldn't need to be manually sorted for the plugin to work, but I just kind of prefer to go top to bottom in my organization based on hours time. Okay, now let's do a transition duration. We can just keep making those 30 seconds. Now, if you wanted to, because these are a resource, you could just share it across all of these times of day. So I could right click here to save as, and I don't know, I might create a folder for durations and then say time of day enter duration and then save that. So now if we expand it, we can see that this is a saved resource, and we could actually reuse that across our other times of day. Now this is totally unnecessary. Feel free to customize the duration for each of them, but if you want to change it once and update in all of these locations, then you can just do that by updating the data here, and it'll propagate to anything that references that same resource. So pretty handy. Okay, and now we need our dusk time of day. So I'll do dusk and then enter time, let's say 6 p.m., so 18 hours. I also want to go back up here and change the daytime color. So let's say that this should be kind of a dark yellow, and then here should be a slightly less dark purple. And then the last one can be the nighttime time of day with an enter time of 20 hours. And we'll use the same transition duration. Okay, and that dark purple works pretty good for nighttime, I think. So that basically defines all of our times of day. Now, if we don't want to lose this set in case, for instance, we delete the day-night cycle system from our game, then we can right-click here and save this in our project. So we have a times of day set. I might just put that under settings and say game times of day set. Okay, now it's saved to the project. It exists outside of the scene and this node now. Okay, so for the calendar, you're almost always going to want to keep the same calendar that your other systems are using so that they consistently calculate anything time-based. So here I'm going to quick load and make sure that's referencing the same game calendar, whether this is the default one or a custom one you created. So now we have the time of day display set up, the day-night cycle system set up, so we can basically just run the scene and the times of day should cycle. So at basically midnight, 0 hours, we're still in night, but when this hits 6 a.m., we should get to the dawn time of day. And there you go, we have just entered dawn, and any of the signals related to the time of day changing would trigger at that moment in time, and then we hit daytime, and eventually at, I think it was 18 hours, we hit nighttime. So I'll wait here a little bit more. We can kind of see that it is going a little bit slow, so feel free to increase the game speed if you want to for testing purposes. And then we have dusk and eventually night, and that's the cycle for our day. Now, just by changing the time of day and doing nothing with it, it's not particularly useful. It's an interesting data point, but we might want to actually add a component into our game so that the time of day actually matters. So let's go into the top-down simple level, and I'm going to create a time of day directional light. So add child node, time of day, directional light 2D. We enter that in, and we can see immediately that all of the colors on our map are way overdone. What we want to change is going to be the blend mode here under light 2D. Change it to mix, and that's going to make it more of a multiplying effect between the color and energy times the base colors, rather than adding the full energy on top of the base colors. So I think it was ending up with like a 2.0 energy or something like that before. Basically, if you do mix, it'll look way better. Okay, so we need a few things here. The time state. So what time state are we reacting to with the directional light? Of course, that's the world time state. So let's quick load that. And then we need a light settings group. So this is a resource we're going to have to create right here. And then the transition curve is optional. So the transition curve, as it goes into the time of day, you have that transition occur over 30 minutes as we set up. Do you want that to be a linear, which is the default? If you don't set a curve, it's just going to be linear by default. Or you can have it change its color settings and light intensity settings in some kind of weird curve. Whatever you set up, it's just going to sample that value and multiply somewhere between the current time of day settings and the last time of day settings. Now, the settings for lighting that I'm talking about actually exist right up here in the light settings group. So we need to create this resource. And I'm actually going to get rid of the curve. We're just going to use linear for right now. So we expand this, and just like the time of day set, we have an array of time of day light settings. So we'll create one for each time of day that we want the light to react to, which in this case is just going to be all of them. So we create 4 time of day light settings resources, and let's create those. For each of these resources, we reference the time of day that we're responding to with these light settings. So we can quick load, and in the project, we'd want to find the times of day that we're using. These current ones actually exist in the other demos and the testing for the plugin. Since this is the dev project, it kind of has everything in it. So where do we get those times of day from? Well, they're resources. So if we go to the top-down simple main and we expand our set, we can set each of these resources inside of our project, which is a good idea because obviously we need to reference that in other places, other nodes. So let's right-click on the time of day for dawn. You might have to make it unique first so that you can save it. So if you need to do that, right-click, make unique, and then right-click and save it. And then in the settings folder, I'll create a times of day folder, and then we'll save it as, let's say, simple dawn tod.tres. I'm just abbreviating time of day because it's kind of long to type out. And then we'll do that for the other ones too. Save. So I'll make it unique for each of these, and then we'll save them. So this is simple daytime TOD, save it. Next one is simple dusk TOD, save it. Last one, simple night TOD, save it. Okay, now that those are all saved, we can go over to the top-down simple level where we have the directional light, and we can just quick load each of these from our project. And because I gave it the simple prefix, I could just type simple, and we have the ones that actually relate to our project. And maybe we didn't even need to do that because the folder over here already has simple, so it would probably match by the search. But anyway, that works fine for the naming. So let's do dawn TOD, and then we need the color for dawn. So what do we want the light to look like at dawn? I would probably put it something like a light blue, and then the energy should be less than daytime, so I'll do 0.85 as the mix, so a little less light intensity than daytime. Then the next one, let's quick load this for daytime TOD. I'll just leave this as color 1.0. So the color will just be the original color of the scene as it was basically originally intended. And then let's do the next TOD light setting and do quick load for dusk. Dusk can be kind of a purplish, but not too dark, not nighttime quite. And then we'll do 0.85 for the energy. And the last one, of course, nighttime. So night TOD. And then we have the color a dark purple, and then the energy I'll just make 0.7. Now you probably don't need to save each of the time of day light settings as an individual resource. You could probably just save the time of day light settings group as a group together resource, and that should be good enough. So I'm going to right click here, save as, and we'll go into the settings, and I will call this outdoor light settings 1.tres. So now all of these nested resources just exist inside of this parent resource, which is inside of our project. Once again, if we ever lose the directional light because we delete it, our settings still exist in the project as a resource. So easy to get back and access or share to other lights if we need to. Okay, that's basically the light setup. So let's go ahead and run not this scene, but the main scene. Remember, it's loading the level. And you should immediately notice that the lighting changes for our level. Now, I didn't customize the intensity or the color of the base light. It's actually using the time of day light settings. So as soon as we get to dawn, you can see that there was that 30-minute transition. And the light settings is an object that actually responds to that transition timing. So basically, you get kind of a cooler effect for your light. And this will, of course, eventually go to dusk, and then nighttime, and keep going through the cycle as our day changes over and over again. And that's the gist of how you can use times of day with the day-night cycle system. From this point, you would just want to add in your own events. So for instance, when dawn occurs, maybe you want something to happen in your game, like all of the plants in your game gain an extra resource because they are ready for harvesting again, for instance. Okay, and you can see, of course, we're on like day 2. This will eventually progress into months and years and so on and so forth. But basically, you get the idea. So there's one more game system inside of the World Time plugin, which is the Age system, the World Age system. So let's add in World Age system and create that. It's called the World Age system because it is going to modify the World Age state. So inside of your game, you might have aging components attached to individual objects, and they would have their own local age. And the local age is going to increase based off of the world age increasing. So in other words, the first object created in your game would be the game world. So we need our world age state. We'll create that in the hierarchy. So just like the world time state, the world age state is going to be a resource we definitely need to share across our different objects. So I'm going to right click on this, save it into our project. I'll find the states folder, and then we'll do world age state save. So this directly supersedes from the previous versions of the plugin, the aging signal bus. It is basically the aging signal bus, except that it also maintains an age state. So you can see in the age state, you have a created age, a total age, and a current. So the created age is the time based on the parent's age, if there is one, where this state was originally created. So the world age state is, of course, going to be created at 0. The world gets created at the start of time. And then the total age is going to progress past the created age. So the total age is basically however many ages have progressed past the created age number. So if 10 units of age elapse in your game, then the total of the world age state would become 10. And then for the current age, we'll get to that more when we're talking about the local age state. For the world age state, because this is only ever created and exists basically indefinitely, the current is going to equal the total. But for a local age state, that's going to be a little different. Okay, so you're probably wondering, what is a age in terms of game terms? So that's basically defined by your aging settings to be what you want it to be. So let's create a new aging settings. I'll expand that, and then you can see the update timing, interval unit, and intervals per age. So the update timing is when is the age going to be progressed. You can have that default on date changed so that when the game increases its day by 1, then the age value of your world age state and anything connected to that world age state with the aging component will go up by 1. So that could be pretty good for like a farming simulator, for instance. You can also change this to a different update timing, like game time elapsed or real time elapsed. With real time elapsed, you could actually just ignore the other systems and just operate this world age system purely based on real time processing through the process function. But more likely, you would probably use game time elapsed, which is going to be using the world time states game seconds in order to determine how much age has increased. And in the case of doing some kind of weird time traveling, you can allow negative age changes if the time state ever gets updated backwards, like going back a day or a year, then you can allow the objects in your game, the age states, to get negative values for the age or to subtract their age. And I think that that is a really niche need, so most people probably just leaving this off. So basically determine, do you want the age to go up with the day changing or just game seconds elapsed? So if you do game seconds elapsed and you want 1 age per hour of game time, then just take your interval unit and set that to hour, and then 1 hour. You can increase the intervals if you want it to be every 2 hours or every 4 hours. So it's basically up to you within your world age system. How often do you want the aging to go up? Now, I do want to point out that you can have more than one world age system and world age state inside of your game. So if you have 2 different sets of aging that you need to do, like some objects increase their values every day, where others increase their values every hour, then you could create 2 separate states. Or you could create a threshold where the objects that need to do something once per day just need 24 units of age to go up, and then you make the interval unit hours instead, where some of your objects would do something every 1 hour. So it's kind of up to you on how you set that up, but basically the idea is age is one of whatever you set it to be in terms of game time. So that could be 1 age per 4 hours. And I think for the demo I'm going to do, I'll make that once every 2 hours. We'll increase the age as the game seconds elapse. Okay, so beyond that, we need to reference the world time state. So I'm going to quick load world time state. If we're increasing the age based on game time elapsed, then we need the signals from the world time state in order to do that. And then the calendar, once again, we'll just use the default game calendar, and that should be good for our needs. Okay, so just with that, the world age should start increasing every 2 hours of game time. But that's not going to really do much for us because nothing in our game has an aging component, so it's not going to be reacting yet to the age increasing. So let's actually create a new scene where we'll have corn seeds turn into a different stage of the plant's evolution when the age increases. So let's add a new scene, and I'll just make this a 2D scene. I'll call this corn seeds, and we will add a child node to that, which will be a sprite 2D. And the sprite 2D, let me look for farming sprites here, coming out of my Gatherer's Exterior art pack if you're interested in that, but I will drag this in. So I actually want to use a sprite atlas, not a direct texture. So let me click the drop down and we'll go to atlas texture, and I expand that and I bring in the atlas to this field here. Now I can click edit region and we can select the corn seeds from here. It's a little hard to get the exact pixels you want unless you turn snap mode onto grid snap, I believe I want. So if we do 8x8 steps, that matches this grid. So I'll select these 4 squares as my seeds, click close. And there's the corn seeds that can exist anywhere in the game world. So I'm going to Control S and save this into the demo. So I'll create a folder for objects. And inside of here, I'll just create a folder called corn. So we're actually going to have 4 or 5 scenes for our corn. As it transitions from one to another, it replaces after it ages. So a folder makes sense. And then I'll save corn seeds inside of here. Or maybe I'll call it corn1 seeds. That should make it a little bit more searchable. So let's save that. Okay, and if I put this into the game level, so maybe in the scene root, I add a child node 2D. I'll call this objects, and then I place corn seeds into the scene here. Okay, so there we have our corn seeds. I'll just drag this somewhere that makes sense, I guess. Not really snapping to the grid or anything here, but close enough. And I'll bring this under objects. I'll duplicate it with Control D. Let's just move some of these corn seeds to other places in our scene. And that should be okay for right now. Let's go back into the corn seeds scene. Now, of course, with no script, this doesn't do anything. It's just a sprite on the screen. Let's right-click on corn seeds, add a child node, aging component. And the aging component is going to need a few resources in order for it to work. So by default, the aging component with a world state and a local state is going to update its local state whenever the age increases on the world state. So why do you need 2 aging states? And I'll go ahead and select the world state here. And then we'll create a new state, a new aging state. You can see that these are both aging state resources. So the reason for that is that your objects may enter the scene or be instanced inside of the scene at a different time than the start of the game. So when the object is created in the scene, and more specifically, the aging component is created for the first time, it's going to take the total age of the world state, and that's going to be set as the created age of the local state, because the object is being created at that time of the total age of the game world. So the total becomes your created here, and then the total of your local state is going to be the total actual amount of age that's occurred in the game world minus the created. So basically how many ages have occurred while this state has existed. And then the current state is for this current iteration of the aging component, how long has it been in the scene? So with scene replacement down here, what's going to happen is this corn seeds is going to be replaced with the next stage of the corn. And when that happens, this age data is going to be sent to that new object, and the current age is going to basically remove the threshold of the scene replacement. So if we had a current age of 5, and then the scene replacement down here was 5 ages, then it's going to subtract 5, it's going to transition this scene into the new scene, and then we know that that second stage of corn has existed for that created age of 0, but the total age, which is the time since the original aging component has been created, will still be 5, and so on and so forth. So the threshold gets subtracted by the current, the total gets passed on, and the created is basically the time that this aging component was originally created with reference to the world state. Hopefully all that makes sense. But basically, at the end of the day, it's just a bunch of numbers behind the scenes. So the scene replacement is an optional resource you can set here. But if you do set it, then what's going to occur is that when the threshold is reached on the local state, it's going to, once again, replace the scene you target, or the target node, with a new scene that replaces it. And it's going to pass along the age data as I just talked about, where basically the new current becomes the old current minus 10, and everything else is the same with the total and created. So we need a new scene for the second stage corns if we want to do that. So for the target path, I'll make that the corn seeds, and then we can duplicate this and create a new one. So I might say corn to sprout, duplicate, and we go into that scene. Now, of course, I'm going to rename this corn sprout. And if we look at the aging component, we can see that the target path updates here with this resource, and it is different from the corn seeds one. which is targeting the corn seeds route in order to replace. So you do have to be careful about that we're dealing with unique resources, because this scene replacement should be different than this one. So now in order to target the corn 2 sprout for being instanced in place of the corn 1 seeds, we simply assign inside of demo, top-down simple, objects, corn, sprout 2 scene, tscn, and save that. Oh, and the actual aging threshold, I'm going to set that to 1 on each of them because I want it to only take 2 hours or 1 unit of age for each replacement. And you could, of course, customize it for each one. Maybe some stages take longer than the others, but let's just make it quick here. So they all get a 1. And then, of course, we're going to need to duplicate the sprout. And I'll just call it corn 3 for right now, corn 4, corn 5. So on each of those, I'm going to target the path for the object I'm trying to replace. So corn 3. And because this is a string path, you do have to be careful. If you rename these, then you're going to need to update the scene replacement paths. The reason I chose to use scene paths here instead of just referencing the packed scene, which can automatically update in terms of the file name changing, is that by referencing a scene inside of a scene inside of a scene inside of a scene, the errors can like propagate up. So if one of your scenes break, all of your scenes can break, and that's not great. So basically having the path to the scene, you'll still be able to open the scene properly. And until you actually try to instance the broken scene, you won't get the errors. So I just thought that that works better here. But yeah, obviously it is a little bit of a trade-off. Okay, so the third one I will call corn 3, just to be really simple here. If I open up the scene replacement, you can see the target path is updated. So now we need the path to corn 4. I'll just drag and drop it, makes it a little simpler. And then we'll do corn 5, double click. I will rename this to be corn 5, aging component, scene replacement. I'll drag the corn into here, and that's looking pretty much good. Okay, so what we still need to do is on each of these scenes, we need to set the correct sprite. So on corn 2 sprout, let's go to the sprite, and we'll select a different texture from the atlas. So that's going to be this one over here. Just drag those 4 squares. Okay, there we have our sprout. Now we need corn 3. Click on the sprite. Go to the texture atlas, and we'll select the next corn. This one needs 6 squares because it's a little taller. And then we got to open corn 4. So for corn 4, let's select that. And then for corn 5, we're going to want that as well. Okay, so if we go through the different stages of the corn, we'll see that they're all centered on the 00 point, which is a little weird because the seeds start at the 00, so this should be kind of where the roots are. And on the further scenes, that we'll see that the roots are actually below the 00 point. So to fix that, you can just select your sprite 2D, hit W, and move it up so that the root actually sits at the 00 point. And we'll do that for all of the scenes. So just W and move it. I'm just going to approximate here, though obviously in the real thing, you want it to get like pixel perfect if you can. So I might just like adjust that over 1 pixel, and yeah, okay, to make it consistent. Two dirt pixels on the left, 1 dirt pixel on the right. And yeah, that should pretty much be okay. Okay. Now I also want to demonstrate that you don't have to necessarily start in the seed stage. We could actually add in some sprouts as well. So if we add in a sprout and we move that over there, maybe a corn 3, then we'll position that there. Okay. Then all of these objects, because they have aging components, are going to receive the age as the world time system ages. And therefore, because they have a scene replacement resource, they're going to do the scene replacement when they hit those certain ages. But once again, I want to emphasize scene replacement is only one example of what you could do with an aging scene object. I also forgot to set 1 path here. So for the aging component on corn 4, let's add that in, and then we, of course, want that to go into corn 5. Okay, and actually, the last scene, the corn 5, we don't actually need a scene replacement there. So we're going to leave that null because once we're at the final stage of the corn, we would just be harvesting the crop, which would just be like a different set of components. Okay, so we have all of our corn seeds and the sprout stages set up inside of our scene. So now if we go over to our main scene and we run the game, the world age system will be able to update all of those seed instances, and it should age and scene replace as time progresses. So remember, we set the aging to occur at every 2 hours. So if we look down here, when we get to 2 hours, the age of everything in the game, or everything with the aging component, goes up by 1, and that occurs every 2 hours. So this is one way that you can basically set up your scenes to age and then replace. So one more example of how you can use aging through the plugins is using the add components. So there's add after game seconds, and then there's add when aging component. The add when aging component is obviously the one regarding aging. So I'm going to add one of those to my corn here. So this is specifically for the corn 5 scene. We'll add in the add when aging component. And the idea is that when the age increases fully on the aging component state, so we're going to have this local state over here. And I gave it a name, corn age. So if you want, you can actually name your resources, which makes it a lot easier to know which one's which in the inspector. Then we want to copy and paste this over to the add when aging component. So if we paste that into target state, then now this is going to react to when that corn age state ages. And then for this component, when the aging occurs at the period, the number of ages that have to pass, it's going to use the amount and add that to either the target node or the target resource, or both if they both happen to be set. So then in my hierarchy, I'm going to right click and add a new node, and I'm going to call this corn counter. So let me search the project for a corn counter GD, and I'll just add that in there. So this script literally just has a export variable, the number of corn as an integer, and the function add that takes a value of float. So for the add when aging component to work, you have to have a function with this signature added to the script that you're targeting, essentially. So we're going to take the value, and we're going to turn it into an integer if it happens to be a non-integer already. And then we're going to add that to the number of corn. And that could be how much corn exists on your corn resource when your player goes to harvest, for instance. So once again, in a nutshell, the aging component is going to age whenever the world state ages, and it's going to increment its age in here. And then when this age resource increases its age to a full value of 1, 2, 3, 4, 5, etc., a full age unit, then it might trigger the add when aging component once the period has been reached. And it's going to take the target node, which we need to assign, so the corn counter, and it's going to call the add function onto that. So when age becomes adding 1 corn to the corn counter. So if we go ahead and run our main scene, of course, the corn counter only exists when we get to the final version of the corn. So if I was to click on one of these, you could quickly see, well, you would be able to see if I paused it, that there was no corn counter. But now if I click on one of the corn counters, we can see that as 2 hours pass to age our game, the age increases on the aging component state and the world state. And then the add when aging component is going to increase the number of resources on our target corn counter node. So you could also use that on a resource as well if you wanted to increase the value in a resource. So that's just one example of how you can use the aging, basically taking the aging state, reacting to the signal, and doing something like adding a value to a different node during your gameplay. So just to show real quick, you can see if I reload the game and show the remote view that the corn seeds only have the aging component. So your different stages of your scenes can, of course, have whichever components they want, whichever nodes they want. So you can customize each version of the corn to do what it needs to do, whether that's being harvestable or just growing into a new state and replacing when the age reaches a threshold. So far for the 1.0 version of World Time, that's about everything that there is included that you need to know about. And you can see how with this plugin, you can create a more dynamic world, being able to change the date, the time of day, the lighting, also able to age scenes into a different evolution of that scene through aging. And you can do things like add resources to nodes as age increases or as game seconds increase during the gameplay. So that's pretty much it for my tutorial on World Time 1.0. I'll be, of course, trying to release new tutorials as I come up with more examples of how you can use the plugin. And you can find the plugin in my links down below on either itch.io, Ko-Fi, or Patreon. So thank you for watching to the end. I've been Chris, and hopefully I'll see you guys in my future video content.